So, good morning, class. So, welcome to semester 6. So, today is your first day in semester 6. And guess what? You're going to do plan design. So, what have you heard about this class? Have you heard about plan design? Maybe from your seniors, maybe from alumni. Can you tell me? Yes? Okay, yes, that's correct. Okay. Anything else? Maybe anyone else? Yes, yes, we're going to deal with a lot of projects. It's going to be forest chaos. Yes. Anything else? Yes, you're correct. So at the end of the project or at the end of the class, you're going to build a report and you're going to present it. Yes, that's correct. Okay, so a lot of you already know or understand about what is this class is about. Yes, okay. So today we are going to do an introduction to plan design. So I'm going to tell you what are you going to expect in the semesters, you're going to do this semesters in this class. Okay? And if I spoke too fast, let's say just raise your hand and then ask me to maybe slow down, or if you have any questions, you can always raise your hand and ask questions on the time instead of waiting up until the end of the class, okay? Right, so first are the rules in my class. So since you are in the sixth semester, you know the rules in my class, right? So first is don't be late. So you know that here in our university, we have rules which is don't be late. So it is not even 1 minute late or I will be lock the door. And then beware of absence because if you have 25% absence, then you cannot go to the final examinations, right? And then you can always wear anything and you like only in my class. Okay, you can wear shorts, you can wear shirts. It's okay. Why? Because what I want your brain or I want your focus in my class. I don't really need your costume. I don't really regard what you're wearing. So it's okay as long as you wear something. Okay. And then feel free to eat or drink during my class because I know it's an 8 a.m. class. Maybe you haven't got your breakfast. It's okay. You can feel free to eat or drink, but you can also feel free to sleep or play games in my class. It's okay. Just don't disturb others and keep the voice to minimum. So you know that we have class next to ours. So please keep your voice to minimum so you don't deserve other class. Okay. So next is regarding the evaluation. So because this is a project class, so you know that it will be different from any other class that we've already have. Okay, so if previously you have quizzes, you have assignments, and then you also have final examinations, but for this project, you have this component as you can see here. Can you see my slides clearly? Yes, okay. So first is the participation in the group discussions. Because this is a project class, so every time you do a project discussion or group discussion, I will see your participation in that group discussion. Alongside with that, your group mates will also send a report to me in any kind of form, maybe through WhatsApp, maybe through a report, log sheets, how active you are in group discussions. Next is the personal report. So at the end of the semester, you're going to submit a report as a group project. Yes, okay. But there will be one part in the group report. There will be a personal report, which is regarding the unit operation chapters, and that one will be inside your personal report, which is the portion is 10%. Next is the midterm report and presentation, which is 10%. So we have 14 weeks, around 11 or 12 chapters throughout the project. So by the end of week 7 or week 8, you're going to submit a midterm report and then you're going to do a midterm presentation. So I will know how far you've gone to your project. So I don't want you to stumble upon at the end because you haven't finished any of your midterm report. And then next is the final report and final presentation. So by week 14, you're going to do final report and you're going to also do the final presentation with half a portion of 30% and also 20%. So the difference is that in this class, we will not have any final examinations. Yes, because it is a project class. Yes, of course. So that is why you're not going to have any final examination. You're going to do the final presentation, and also final report. Okay, so anyone have questions up until here? Or maybe you want to have a final presentation and a final exam as well? No? Okay, let's continue then. Okay, so what to expect? So here in our class, there will be 4 SKS, means it is 4 hours meetings per week. And what we are going to do is, will be 1 hour, I will do a general explanations about the subtopics. So as I mentioned earlier, we will have 14 weeks of meetings. There will be around 11 to 12 sub-chapters. And then each week, I will be explaining to you the subtopics for this week. And what I want you to understand is that the topics will be a continual topic. What does it mean? It means that you need to finish the previous week topics before you can continue to the next one. Okay, so remember, before we continue to this week's chapters, it means you need to finish up with last week's chapters. Okay, and then after I explain about the subtopics of the week, then I will give you 2 hours of a group discussion in class. And then you're going to do 1 hour of a progress report. What have you discussed in class this week? Okay, and during the progress report or during the group discussion, we can also discuss previous chapters. Maybe there are some things that you haven't understand or you haven't finished up. You can do that as well. Okay. Any question so far? Maybe someone at the back? No? Okay. Right. So next is log sheet. So this is how I know or how I understand how active you are in a group discussion. Because maybe the 4 hours in class is not enough. So maybe you will need half time to do somewhere in Starbucks or in the cafe to do this project. It's okay. What I need you to do is I need you to fill up this log sheet. So each group will need to submit the log sheet at the end of the report, and then you need to put the date here. So when do you do the discussion and who active participate in that discussion here, and also what is the subtopic covered, and I will sign each week when we meet in class. Okay. Right. So next one is a timeline. Because this is a group project, so there will be a timeline, and I want you to understand. Because as I previously mentioned, that the project or the sub-chapters will be connected with each other. Let's say you need to do the energy balance part. So this is the mass balance. In week 5, you need to do energy balance, right? So you need to finish up the mass balance first before you can continue with energy balance. Because if you haven't finished the mass balance, you cannot do the energy balance like the one that you did during the, I don't know, second semester, if I'm not mistaken, right? Okay, so the first week, which is today, what we are going to do is we are going to do the introduction to plan design and also the most important part, which is the project determination. So later today, after I explain everything, what I want you to do is I want you to create a group, maybe 4 or 5 person each group, and I want you to discuss what kind of project that you want to do during this class. Okay, so later maybe I will give you like hints what I expected for you to do. Maybe I can also give you an example from your seniors or from your alumni, what kind of projects that they do in the plan design. Okay, and then next week, what you're going to do is the forecasting or market. So because at the end of the day, what you want to know is not only determine the project, and you need to know where do you want to sell your product, and then how much you want to produce in a year, let's say, and then what is the forecasted product for 20 years later. Because when you build a plant, you don't only think for 2 years, 5 years. You need to think about 10 years, 12 years in advance. Okay. Next is the root process and also Kepner trigonometric. So in here, in the third week, you're going to determine how you're going to create your product. So you're going to think about the process design. You're going to think about what kind of raw materials, what kind of equipments, things like that, you're going to determine using a root process. So you need to read a lot of journals that stated how to create the product that you want to produce. Okay, and then using a Kepler trigonometrics. Have you ever heard about Kepler trigonometrics? Maybe somewhere at the back? No? Well, yes, because Kepler trigonometric usually used in a business and social science faculty. But we are here in the chemical engineering department. We also use a Kepler trigonometric. So a Kepler trigonometrics is basically a way for a system to show us which one or which root process is the best for your product. So let's say you have 4 different root process. Using a Kepler trigonometrics, they will show which one from the 4 root process is the best for you. Next is, in the 4th week, we are going to do a block diagram and also mass balance. So do you still remember about block diagram? Or maybe the difference? So block diagram versus process flow diagram. Yes, this one is a PFD. Yes, thank you for still remembering that. So do you still remember what is the difference between block diagram and process flow diagram? So block diagram means that we regard the process as a block. So we don't think if it is heating, if it is mixing, if it is packaging, we don't regard that. We only regard this as a block. So we can see something like this. Remember, always put the numbers on your streams, right? So 2, 3, 4, 5, and I always put a number also in the process as well. So this is what we call as a block diagram. Hope you still remember this. So in the block diagram, we don't really regard what is this process. It can be mixing, it can be heating, we don't really regard that. Okay, and then in a process block diagram, this is what we call as an IPO system. Do you still remember what is an IPO system? Yes, IPO system. Yes, that is correct. IPO means input process output system. Why? Because here, only using a block diagram, you can know which one is the input, which one then is the output, and which one is the process. How? By using this streams. So that is why you need to use arrows, because the arrow shows which material or which energy going in or going out from our system. Okay, and what is the difference with the PFD? So PFD is an advanced version of a block diagram. What does it mean? It means that it is using a specific unit or a specific symbol that shows us what kind of equipment that we use. Let's say this first part is a mixing, and let's say this one is a heating. If it is in block diagram, we don't really regard that. We just draw it as a block. But here in a process flow diagram, we already use what kind of mixing equipment that we use. So do you remember the type of mixing equipment there is? We have batch mixing, we have continuous mixing. Anything else? Continuous stir tank reactor, yes. Plug flow mixing, yes. Anything else? Right, so we have, let's say, if I have a CSTR, so continuous stirred tank reactor over here, which is a CSTR. So I already need to use the exact symbol for the CSTR. And also, let's say the heating, let's say I'm using oven. So this is the exact symbol for oven, let's say. Oh. Don't forget to always give numbers to your flow. So this is exactly the same process, but have 2 different functions. Here in the block diagram, we only want to know what is going in and going out. But here in the process flow diagram, it already showed what kind of equipment do you use. And why is it important? Because as a chemical engineers, we don't work alone, especially when we design a plant. We will work with electrical engineers. We will work with mechanical engineers. And the PFD, the process flow diagram, is how we communicate, how we understand each other. So this is like a language specially made only for an engineers. And then after you create the block diagram, you also need to calculate the mass balance, right? And then next is energy balance. After you finish up with the energy balance, you need to calculate the energy balance, and then you will have time during this week 6 to do a group discussion. Before in the week 7, you're going to do a midterm report and also a midterm presentations. And then during week 8, after midterm presentation, you're going to do fluid mechanics. So do you still remember what do you learn in fluid mechanics? Yes, you're going to calculate the pipes, you're going to calculate the pumps, you're going to determine the pipe types, to determine the velocity of liquid inside of a pipe. Yes, that's correct. Thank you. Next is a PNID, piping and instrumental diagram. So piping and instrumental diagram is a diagram that is more advanced than the process flow diagram, that it will show all the instrument that you're going to use inside of your plant. Both safety instrument or even instrument that you need to use to ensure that your design is correct. Next, in the week 10, you're going to the plan location and floor plan. So this is where you're going to determine where do you want to build your plan, how big your plan will be, and then how many workers that you're going to use, how many supervisors, how many operators, let's say. And then week 11 is going to be plant safety. So you're going to determine how safe it is your plant to operate. You're going to use hazard. If you still remember, what is hazard? Yes, it's hazard and operation. So you're going to do a qualitative safety analysis method for this. And then week 12, you're going to do engineering economy. So you just have engineering economy last semester, if I'm not mistaken, right? So I'm sure you can do that. So why? Because at the end of the day, if you have state-of-the-art equipment, if you want to create a very unique product, but if it is not going to give you profit, then there will be no investors going to invest in your plant. And of course, that is not our goal. And then in week 13, you're going to have a group discussion and final report submission. And then during our last week, you're going to do a final presentation. And then at the final presentation, there will be not only me, so I will ask for other lecturers as well. I will ask the dean maybe, or I will ask other lecturers to come sit and give comments on your design. Any question so far? No? Okay, so plan design. What is plan design? Plan design is planning, designing, specifying, installing, modifying, maintaining plant facility system and equipment. What does it mean? So when we design a plant, we just don't design it. We think about how to install an equipment, how to maintain the plant facilities. And that is the job of the chemical engineers. Okay, so here in the plant design, there are two types of projects, greenfield and brownfield. Do you know what is the difference? Can somebody tell me? No? Anyone at the back? No? Okay, so greenfield means that there is a client, let's say, come to us and then they will ask, can you create a plant? And then we have nothing. Means that they just borrow land, or maybe um, they just think about creating a product. So this is what we call a greenfield. While brownfield means that when there is a client or when there is a company that they already have a plant running and they want to expand their plant. Maybe they want to add more warehouse. Maybe they want to add more operation line. Maybe they want to add laboratorium, let's say. So this is what we call as a brownfield project. Okay, my next question will be, which one do you think will be easier, greenfield or brownfield? Yes? Okay, so of course it is, each one will have their own pros and cons, because in green fields, you will have a lot of um, possibility to do. You can have a small plant, you can have a big plant, you can have small equipment, large equipment, you can build a soccer field, let's say, in your plant. Is entirely up to you as the designer, yes. But because we have so many possibilities, somehow it is very hard to determine what kind of planet we want to do. Well, if it is in brownfield, of course, the cons will be there will be so many restricted areas. So you cannot stop the plan that is already running to stop for you to build another line, right? So you need to work along the timeline. So maybe you need to do it like 2 a.m., 3 a.m. in the morning, things like that. But of course, it is a smaller scale in comparison to the greenfield project. Okay, so this is the 5 steps in designing a real plant. Okay, so here, can you see? So first is a conceptual design, or we call it a CD, and then basic design, which we call it a BD, and then detail design, a DD, and then the construction, and last one is validation and commissioning. So what is the difference between CD, BD, DD, construction, and validation and commissioning? Anyone know? Anyone have ever built a plant before? Okay, so CD is a conceptual design. So this is where this project will be headed. Okay, so in this class, I will expect you to only create a CD. So CD is already a whole engineering calculation is already put in there. So you already determine what kind of product, mass balance, fluids, layout, blah, 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 everything is already there. But the difference is that usually is the percentage of error allowed. If it is in CD, the percentage of error allowed is usually around 30%. And then once it's finished with CD, we are going to go to BD, means that more and more engineers will work on that, and then the percentage of error allowed will down into 20%, goes into DD, and DD, the allowed percentage of error will down to 10%. After that, it's going to do a construction, so the building construction, and then last one is validation and commissioning. So the whole time, usually the time needed to build an actual plan is roughly 3 to 4 years. So it's not like one night or one day type of project. Of course, it is not. So CD or conceptual design usually around 4 to 6 months, which is the perfect time for you to do the project in class. Okay, any question so far? Right, so maybe my last 2 slides. So here in the plan design, so why is it important? Because plan design is a very specific subject that we as a chemical engineers can do. So in the whole wide world, the one that can do a plan design is only us, chemical engineers. So you should be proud on that. Okay, so what is that? Because in plan design, you're going to correlate everything that you've already learned in the past 3 years, from your first semester up to your 6 semesters. You're going to use your knowledge in unit operations. You're going to use your knowledge in material balance, energy balance, fluid mechanics, engineering economy. Everything will be put together inside this class, which is plan design. I always remember back in my days, I don't know, a decade ago when I was a bachelor degree student, I always think, why do I want to learn chemical engineering? Or why should I learn mass balance? Why should I learn energy balance? But I find the answer here in the plan design class, because everything makes sense now. Everything that I've already learned previously is being used into this one class. And why? Because plan design is $1 million knowledge. Clients will pay you a lot of money if you can do this. Okay, so I expect greatness from all of you guys here. Okay, good luck. Right, so any questions so far? If no, then today, as I mentioned, we are going to do the project determination. So you need to determine your own group. So it will be 4 to 5 person in each group. And you're going to provide me with at least 3 different types of projects or what kind of products that you want to produce this semesters. And since we are chemical engineers, I expect you to maybe give a glimpse of a chemical industry, but it is not only a chemical industry related. You can do food industry, you can do a chemical industry, you can do biochemical industry, is entirely up to you. So discuss with your group mates. At the end of the class, then we are going to have a discussion. I expect at least 3 projects. Then we are going to discuss from those 3 possibility of project, which one is the best one for your groups. Okay? Any questions? No? Right. So good luck and let's get started. Thank you.